Okay, this recording was done in front of a live studio audience. Okay, good. This is the answer key to the last part to our Chapter 8 quiz. This inequality here we solve, you have to put these on a number line. Okay, there's a whole bunch of numbers that make this a solution to the equation. So you put them on a number line. Boundary points, one boundary point. Dempsey, one boundary point on here. One value that x cannot be. Come on, you got this, bud. Rupee, stop telling him the answer. It's not funny. Okay, you're undermining his intelligence. One value x cannot be for sure, because if you divide by 0, it will blow up the mathematical universe. Everything just blows. Good. So that's going to be a boundary on our number line. I'm just going to write it over here for now because I don't know exactly where it goes. Okay. The other boundary you get when you solve this like it was an equation. So I take this, I pretend it was an equation, and I solve away. So solve away. This is where you can do your precious heart method, right? Or cross products. So your cross products end up being x equal to 3 times x minus 6. And don't forget you have to distribute the 3. So that ends up 3x minus 18 equal to x. Move the x over, you get negative 2x equal to negative 18. So then x is equal to 9. And there's your other boundary for your number line. So 6 and 9 are the circles that are not, or are they going to be filled in? So can they be filled in, yes or no? One of them can, the 9 can. And why can't the 6 be? Because if it fills in and it equals 6, it's going to be dividing by 0. If it divides by 0, then we have undefined. It's not defined to be divided by 0. So now we test in between there and see if it's true. So I pick a value in between here. Let's pick 7. And let's test to see if x equals 7 makes this true. So I put a 7 in for x. Is 7 divided by 7 minus 6 is 1. Is 7 over 1 less than or equal to 3? No. So it's false here, which means it's always or almost always going to be true there. And if I test a value, like let's say I put 0 in there, is 0 less than 3? True. If I put a 10 in there, is 10 fourths less than 3? That's also true. So then your final solution for this one would be x has to be less than 6, or you have to include the word or. It's a disjunction, x greater than or equal to 9. Any further questions on that one? Okay. Okay, here we go with an equation. If we want to solve an equation with a bunch of fractions in it, we want to get all the denominators to be the same. They said same if you didn't hear that at home. So I'm going to factor this one here to be, hey, did you guys know it's my birthday today? No. Yeah. My birthday day.
Let's sing happy birthday right now.
Not right now. Maybe later. So 2x plus 4, 2 times x plus 4, that's going to be your common denominator. This one right here, this middle term here, the x over 2, that needs an x plus 4 in it, so I multiply top and bottom there. And then over here, this one needs a 2, top and bottom, right? So now all my denominators, let's see if I can get on, hello, if I can get it, this computer's seen better days. All the denominators match, see? 2x plus 4, 2x plus 4, 2x plus 4. So I don't care about those anymore. All I'm going to do is solve my numerators. So I get the numerators, I clean those up. 2x plus, right here, I get x squared plus 4x. Some people are forgetting to put the x on the 4. Okay? Don't do that. Don't forget to distribute this, see? The x goes there. It goes there, that's in parentheses. And then that equals, I didn't have to do anything to 2x, so it just equaled 2x there. Move this over to the other side by subtracting it, and it's going to cancel that out. So I have a 2x on each side. So those cancel each other out, and I'm left with x plus 4x equals 0. This one really stuffed a lot of people up. You just kind of forgot about how to factor this, but I can just factor an x out of each term. X times x plus 4 equal to 0. My two solutions or possible solutions are 0 or negative 4. I have to check to see if they're extraneous or not, or they make a denominator 0. So go up all the way to the top, and guess what? Negative 4 doesn't actually work. So the only one that works is 0. Okay, let's give a round of applause for how that was a great problem. Let's go. That's a good one. All right. Okay, good job. All right. Last two are word problems. Team A can wash all the windows in the school in X hours, so we don't know how many hours it takes them. It takes Team B 3 hours to do the same job. So they do all the windows 3 hours. If they work together, they can do it in 8.5 hours. So 8.5 hours together. Team A, we don't know. And Team B takes 3 hours longer. Oofta. Okay, so we don't know the rate. But we do know that they worked for 8.5 hours and they got the job done. So what that tells me is if they work for 8.5 hours, and I don't know their rate, together, they are going to get one job done. And I didn't know their rate, but I know that one of the rates was 3 hours longer than the other. So that this team would get X would be their rate of how many hours it takes to do the whole school. And then this one would be X plus 3. All right. Looks easy when I set it up, huh? This is kind of a hard problem, but some of you got it. So if you got it, great job. Otherwise, if you didn't, I mean, this is a tricky one. So to solve this, we get a common denominator just like we did the last one, would be the product of x and x plus 3. So this one needs an x. This one needs x plus 3. And this one needs both, which would be x squared plus 3x. Solve away on that. Simplify this up here, you get 8.5x plus, let's see, 24 and 1.5 is what, 25.5 plus 8.5x equals. Okay, clean that up. We have, let's see, x squared. Let's do it on this side. So we have x squared. How many x's? That and that together make 17x. And if we move those 17x's over here, they're going to be negative. So they show up as a total of negative 14x. And then if we move this 25.5 over, that becomes minus 25.5. So this is kind of an ugly one, which I think was the hint I gave you on the quiz. This one was ugly. So now you have to use quadratic formula to solve this, and that would be the opposite of 14, so that would be actually positive 14 plus or minus the square root of 14 squared minus 4 times 1 times negative 25.5 all over 2. Okay, well, 14 over 2 plus or minus the square root of, what is this stuff in here? That's 196 minus negative 25.5 times 4 is going to be 102, I believe. So minus 102 is going to give you a total of 298. So the square root of 298, and then that's all over 2 as well. If you figure that out, it's 7 plus or minus the square root of 298 over 2. Ended up being, I don't know what that is off the top of my head, but I calculated it out, and it was 15.6 hours, rounded to the nearest tenth, which 1/10 of an hour is 6 minutes. So this is what, 15 hours and 36 minutes. So that was a doozy of a question, especially because you had to use quadratic formula. So, but nonetheless, that covers a lot of stuff that we've done this semester. So there's that question. Train traveled 120 miles from Freeport to Chicago and returned the same distance. So the distance is the same. We've been putting together distance, speed, and time graphic organizers for these problems. So we've been doing distance, speed, and time. The distance in this is the same. So many of you tried setting this up and you had 120 and 120. And if you set it up correctly, I think I gave you 2/3 of the points. So 120, 120, distance is the same. One train travels 20 miles an hour slower on the return trip. So 20 miles an hour slower means that one speed is x, the other speed is x. Now there's two ways of thinking. You could make this x plus 20, or you could make one x minus 20. What do you like to work with more, plus or minus? Minus? I like to work with plus. So I'm going to trump you on that one, sir. You can do either one. I'd rather work with positive. So this is the x plus 20 is a faster train, x is a slower train. So the time, this is where people get goofed up. They want to put like something to do with the number 5 in this time slot, but it's not 5. That's not what we want there. We want that as an expression of distance over speed. So that's 120 over x, and here is 120 over x plus 20. Okay, now the big ticket here is that a total time of 5 hours means that this time plus that time equals 5 hours. So when you set this up, you say 120 over x plus 120 over, this is the time of the faster train, so the slower train time plus the faster train time has a total of 5 hours. And then now this is just a rational equation that you get common denominators and solve. Common denominator is the product of x and x plus 20. So this one needs an x plus 20. This one needs an x. This one needs both, x squared plus 20x. So you get big numbers here, but this one ends up factoring. So if we clean this up, we get, let's see, 120x plus, what is that, 2,400? And we get over here plus 120x, and then that equals x squared plus 100x. So another quadratic equation to solve. Get it equal to 0, see if it factors. And so here we got 120x there, 120x there. Those together make a total of 240. If I put the 240 over here by subtracting it, it ends up being a negative 140x over here. So we have 5x squared minus 140x. And then if I end up moving the 2400 over here, it ends up as a negative as well. And then all the quadratics we want equal to 0. So now my quadratics set equal to 0. I notice right away that I can factor out of 5, so I do that. Factor out of 5 from everything, and I'm left with 28. And then let's see here, minus, if I factor 10 out, I'd have 240, so that means I double that to get 480. All right, and then this actually factors. Yeah, thank you, 28x. So that factors of 480 that have a difference of 28 are 4